Hi everybody. Now this session we will be studying about what is Apache Hadoop. Okay, so let's talk about Apache Hadoop. Talking about Hadoop, basically Hadoop is a framework for running the applications on the large cluster built of commodity hardware. This framework transparently provides application both reliability and data motion. Hadoop implements a computational paradigm named MapReduce, where the application is divided into many small fragments of work, each of which may be executed or re-executed on any node in the cluster. In addition, it provides a distributed file system, that is HDFS. The full form is Hadoop Distributed File System, that stores the data on the compute nodes, providing very high aggregate bandwidth across the cluster. Both MapReduce and Hadoop Distributed File System are designed so that node failure are automatically handled by the framework. So Hadoop is basically not one thing, it is a collection of tools and technologies. Talking further about Apache Hadoop, Hadoop was inspired by Google's MapReduce, a software framework in which an application is broken down into numerous small parts. Any of these parts, that is also called fragments or blocks, can be run on any node in the cluster. Hadoop was created by Dow Cutting and Mike Caffarella. Dow Cutting named the framework after his child's stuffed toy elephant. The current Apache Hadoop ecosystem consists of Hadoop kernel, MapReduce, the Hadoop distributed file system, and a number of related projects such as Hive, as we're talking about right now, Apache HBase, and Zookeeper. So Hadoop is an open source software project that enables the distributed processing of large sets across the commodity hardware. It is designed to scale up from a single server to thousands of machines with high degree of fault tolerance. Rather than relying on the high-end hardware, the resiliency of these clusters come from the software's ability to detect and handle failures at the application layer. Moving on further to the core components of Apache Hadoop. So HDFS and MapReduce are the two core components of Apache Hadoop. The most important aspect of Hadoop is both HDFS and MapReduce are designed with each other in mind and each are co-deployed such that there is single cluster and thus provides the ability to move the computation to the data on or and not the other way around. So thus the storage system is not physically separate from the processing system here. So talking about the first core component, that is HDFS, Hadoop Distributed File System. Now HDFS is distributed file system that provides high throughput to access data. It provides a limited interface for managing the file system to allow it to scale and provide high throughput. HDFS creates multiple replicas of each data block and distributes them on computers throughout a cluster to enable reliable and rapid access. The main components when we consider HDFS are name node, that is the master of the system. It maintains the name system, that is directories and files, and manages the block which represents on the data node. Which are present on the data node. Now, what are data nodes? Data nodes are the slaves which are deployed on each machine and provide the actual storage. Secondary name node is also there, which is responsible for performing the periodic checkpoints. In the event of name node failure, you can restart the name node using this checkpoint. Talking about the MapReduce programming model, MapReduce is a framework for performing the distributed data processing using MapReduce programming paradigm. In MapReduce paradigm, each job has a user-defined map phase, which is parallel, share nothing processing of input, and followed by a user-defined reduce phase, where the output of the map phase is aggregated. Typically, the HDFS is the storage system for both input and output of the map jobs. The main components consist of the job tracker, the task tracker, and the job history server. The job tracker is the master of the system which manages the job and resources in the cluster. The job tracker tries to schedule each map as close to the actual data being processed, that is the task tracker, which is running on the same data node as the underlying block. The task tracker are the slave which are deployed on each machine. They are responsible for running the map in the reduced task as instructed by the job tracker. Talking about the job history server, it is a daemon that serves historical information about the completed application. The job history server can be co-deployed with the job tracker, but we recommend to run it as a separate daemon. So this is about the core components of Apache Hadoop, and this is all about the Hadoop.